dy dx equals what? Well, I'm going to make the first bit the green bit, and I'm going to make the second bit, the e to the x bit, the blue bit. So I'm going to keep the bit on the left, differentiate the bit on the right, plus differentiate the bit on the left, keep the bit on the right. Let's take a look. So keep the x is just x, differentiate e to the x is e to the x. Plus, next part, differentiate the part on the left, that's just a 1, and keep it, that's e to the x. So I've just done that first part there. Let's keep going. So same again, two functions of x next to each other. I'm going to make this the green bit, the blue bit. So keep the x squared, differentiate the differentiate the natural log of x, which is going to be 1 over x. Okay, plus differentiate the x squared bit, it's going to be 2x, and then keep the blue bit, it's going to be natural log of x. Okay, cleaning up a little bit, that 1 we can ignore, x squared, 1 over x, those cancel out. So the final answer then is going to be x e to the x plus e to the x plus x plus 2x natural log of x. As simple as that. Let's try another one. So for the next one, dy dx equals, and I'm going to keep that bit, and differentiate, and then I'll do differentiate and keep again. This one here, to avoid any confusion, I'm going to include the sign before. So I'm going to sort of like put a plus sign there in between. Okay, it'll make a bit more sense in a minute. Let's go. So keep the 3x to the 4, differentiate the e to the x, still e to the x. What's next? Differentiate. So 3x to the 4, that becomes 12x cubed. And then keep the e to the x, e to the x. Okay, so that's the first bit there on the left, done. Okay, minus 5x, keep that. And then differentiate the sine x. So that's cos x. And one more time, so differentiate minus 5x. Now you get minus 5, and then keep sine x, you get just sine x. And look, the sines have taken care of themselves as well. And that's it. So really quick, that one. The final one is a bit of a challenge, so let's have a go at that one. You need to know implicit differentiation for this one. So I'm going to say dy dx equals, and then I've got quite a few bits and pieces this time. So let's just go through and pick what they're going to be. In fact, I could just do it like this, save a little bit of time. We don't have any negatives to worry about. So there's 8 there, 8 pieces. So I'm going to get quite a long expression this time. Let's try and speed up a little bit then. So keep, differentiate. This is implicit differentiation if you're wondering where that comes from. Keep, differentiate. So now we need to do differentiate and keep. So that's the first bit done. Okay, let's do the next bit. So x squared, keep that. Differentiate the y. Again, it's implicit differentiation. It's going to be dy dx. And then differentiate and keep. Okay, so we've now done the first 2 terms. Let's keep going. X squared, we're going to keep that. And we're going to differentiate y squared, which is going to be 2y dy dx. And now the other way around this time. So differentiate and keep, like so. Almost there. So keep, differentiate, it's going to be another x e to the x. And differentiate, keep. So differentiate, keep. Okay. So I'm going to just jump ahead a little bit for the next part, but the idea is you should put all the dy dx terms on one side. You've got other ones on the other side. You factorize and you solve. So let's have a look at that. Okay, and there we go, jumping ahead a little bit, just to explain, I put all the dy dx terms on the left, the others on the right-hand side. I factorized dy dx out of all of this sort of stuff over here, and then I moved it over to the other side. So the final answer is what you've got here.